Okay, hey guys. This video is in relation to chapter 8c. It's looking at question 3. It is a complex familiar question, so I thought I'd talk it through. Question 4 is very similar, so my suggestion would be to work with me as I work through this one. Then you can go and attempt question 4 on your own. So, question 3 is complex familiar for two reasons. Complex that it has multiple steps. Familiar in the way that we are going to be using a formula that we know. If you're looking at this formula, hopefully you'll realise this is the annuities formula that we did in chapter 8c, example 4. So, let's have a look at the question. It says a reducing balance loan of $90,000 is to be repaid with monthly repayments. Interest on this loan will be charged at a rate of 11%, compounding monthly. The loan will be repaid over 30 years, so 30 times 12 is 360. Determine the repayment amount and then work out the balance of the loan after 4 years. So straight away, this first question, we actually aren't looking for this amount. We're looking for this amount, what the repayment is. So let's have a look at what information we are given to see if we can solve this algebraically. So first of all, what do you think our A value needs to be? If I want to know what repayment I need to make in order to pay off that loan over the 360 repayments. Well, I want it to be 0 because that means I've paid it off completely. My principal is going to be what my loan starts at, which is $90,000. In terms of my interest rate, they said it was 11%, but it's compounding monthly. Now, that gives me quite a decimal, so I'm just going to leave it in its fractional form. Now, N value would be the amount of compounds times the amount of years, which would be 12 times 30, which gives us 360. But they told us the 360 straight away from the question. So let's have a look. Have we got the information we need? Well, I've got an A value, I've got a P, I've got an I and an N, an I and an N, and an I. Excellent. So the only one I'm missing is the capital R value, which means I can solve this algebraically. Now, I will let you know, you do need a fair bit of space for this algebra that I'm about to show you. I'll try and spread it out as best I can. So the first thing I'll do is I'm going to substitute in what I know, put it into my formula. Now, I'll probably use this space and then I'll go up and use this space and see if we can get R on its own. So A is equal to 0. I might do it in a slightly different colour, just so it stands out. So A is equal to 0. I'm just going to put this right in the middle because there's going to be a fair bit of swapping and changing. P value is 90,000. My I value is 0.11 over 12. My N value is 360. Minus R, which I don't know. Plus 0.111 over 12. I think I said 0.111 then, just 0.11. To 360 minus 1 all over I. So let me just move, oh bummer. Just move that bracket out there so we're all good with that. Okay, I want to get this one on its own. So we want to have a look at, is there any additional subtraction? Because remember, when we're rearranging equations, instead of BOMDAS, it's SADMOD. Now straight away what I can see is a subtraction sign. So I'm going to move this whole part of the equation to the left hand side. So now I'm going to have 0 plus R bracket 1 plus 0.11 over, whoopsies, not over 360. Where did my little tea towel go? There it is. I need that to be the number 12. This to be 360. Now, I keep messing up where my bracket goes, but this is meant to encapsulate this whole thing. So if you see me cutting corners, give me a wave. So that equals 90,000 bracket 1 plus 0.11 over 12 to 360. So now I have a left hand side and a right hand side. I know it's a little bit wishy-washy in how cramped it is, so I do apologise for that. what we need to do now is get R on its own. It might seem a bit counterproductive me moving this across, but it's going to make it easy for me now. This is a multiply sign. R multiplied by what's in that bracket. That whole bracket is equal to a value. So in order to move it to the other side, I'm going to divide. So now I'm going to have R equals, I'm disregarding that 0 now because it's not doing anything to my equation, 9,000, 1 plus 0.11 over 12 to 360, divide by what was on my left hand side. Now some people may ask, why don't you just put in the value? You can definitely do that and then do your final answer and round there. I just wanted to show where everything was moving whilst we're doing this example. So I'm going to pop this into my calculator now. Oh, bugger. Sorry, guys. Oh, sorry guys, I'm having some issues with my calculator. That's better. So when I put that into my calculator, $85.71, I've rounded that. So, put my approximate, 85,709, which is 85.71. So I've been able to work out what the monthly repayment will be. Now what I need to do is apply it to the annuities formula, just like we normally would do in a simple familiar question, with this as my repayment value, using the time period suggested, so it wants us to do it for 4 years. The only thing that will change is our end value will be for 4 years, so it's going to be 12 times 4. So that'll give us something slightly different there, that'll give us 48. The p-value will remain the same, the interest rate will remain the same. So I'd love you guys to have an attempt at that question. Let me know how you go. Do question 4 as some extra practice. Okay guys, what you'll notice in chapter 8c, I've just had to add this onto the end. I got $85.71. I made an error. I put 9,000 here. It should be 90,000. So that was my fault. You've probably entered it into your calculator correctly. So this just changes it to $857.10. which is a lot better and a lot more reasonable for an answer. So my apologies for that. I cancelled the video a little bit quickly. So it should be 857.10 approximately. Other than that, working's all good. It's just I did 9,000 instead of 90,000. So my apologies. But again, have a crack at question 4 and I'll look forward to hearing from you. Bye.